Here we are at problem 71 from the Honors Algebra 2 summer packet. I have to apologize. I'm not really sure why the link was dead. I even went back into my YouTube channel and it was gone. So not really sure what happened there, but I really want to thank those that were emailing me. There were 2 individuals. So I really do appreciate you contacting me about that so I can get these up and running for everyone. Now, for 71, we have the square root of 24. And if you've had me in the past, which actually this year I don't think I have any students that I've had in the past, but one thing that we talked about in my honors geometry class was this idea of a good and a garbage. And what we do with good and garbage is simply take that list of perfect squares. So if you think about like 1 squared is 1, and 2 squared is 4, 3 squared is 9, 4 squared is 16, and you can go on and on and on and on. But the idea between this good and garbage is we're trying to take this number 24 and divide it by anything from this right side of the list. So is 24 evenly divisible by like 1, 4, 9, or 16? And the answer is yes. It's actually divisible by 4. And as a result, because it is divisible evenly by 4, we're going to go ahead and place 4 inside of that good square root. Now, we still have a garbage, and in order to get the value or number for that garbage one, we're going to go ahead and take 24 and divide it by this number 4 that went in our good. Well, 24 divided by 4 is 6. And so that's where we're just going to throw it in our garbage one. So that number that we had originally, 24, can be split up or broken up into the square root of 4 times the square root of 6. And really the whole purpose why we're doing good and garbage is so that you can kind of pull things out of this square root, this original square root. And if you look at it, the square root, at least the good one, if you look at the square root of 4, well, the square root of 4 is just, we know, 2. And the beautiful thing about this good and garbage method is that for the garbage, you literally just drop it down. Like, that's it. And so the garbage, you don't change at all. Just the good one, you're really actually doing like a square root for. So that would be problem 71. That's really all it is for 71. For 72, we notice that we have a square root of 48 divided by 6. Well, there are some properties with square roots that say that we can actually go ahead and divide within that square root. So 48 divided by 6 simply just comes out to be 8. So we still then have the square root of 8. And now we're pretty much in that same position we were a moment ago with 71, where we're just going to go ahead and do our good and our garbage. Then also we have our list of perfect squares, so 1, 4, 9, 16, and so on. And is the number 8 divisible by any of these numbers? And the answer is yes. You can see that it's obviously 4. 8 is evenly divisible by 4, and as a result, we're going to go ahead and place 4 into our good. Now 8 divided by 4 just comes out to be 2, and as a result of that, we're going to go ahead and throw 2 inside of our garbage. And then we're pretty much, again, doing the exact same thing we did with 71. The square root of 4 just comes out to be 2. The garbage, he just drops down. So we have the square root of 2. So our final answer just comes out to be 2 square root of 2. And again, that is 73. Moving on to 73, we have the square root of 1/2. Well, unfortunately, right here, nothing can really be simplified or broken down. And as a result, then, we're going to have to try and maybe use some other techniques in algebra. And one technique that we've learned is the idea that you can actually go ahead and break up a square root. So I'm going to go ahead and take this original square root and tear it up into the square root of 1 on top divided by the square root of 2 on the bottom. Now, there is a little rule in math, and unfortunately it says you can never, ever, ever, ever have this square root on the bottom. It's unfortunate, but It's in there. So, in fact, actually, I'm just going to do, no. We'll just continue on from here. So yeah, we have that rule that says you can't do the square root on the bottom. So one thing that we can do is multiply it by something to get rid of that square root. Well, just over to the side for a moment, if I was to have like this number, let's say 3 divided by 3. Well, 3 divided by 3 is simply just 1. That doesn't really change anything. What about like 5 divided by 5? That is also the same thing as saying 1. 8 divided by 8, again, same thing, 1. Anything, really, divided by itself just comes out to be 1. And anytime you take like a number, we'll say, just so it's a little different, if we have like 4, and you multiply it by 1, well, you haven't really changed anything. That's still 4. And as a result, we can then say, instead of writing 1 and multiplying it by 1, we can rewrite this thing and say, if we really wanted to, let's extend that page. We could say 4 then times, we'll go with 8 divided by 8. Again, since it was a moment ago the same thing as 1, we can go ahead and rewrite 4 times 8 divided by 8. And we really should end up with the same thing, 4. Well, just let's experiment a little bit. 4 times 8 gives you 32. And this is still all over 8. Well, what's 32 divided by 8? Comes out to be 4. And so you can kind of see just with that like little quick proof that when you multiply things that aren't necessarily 1, but kind of like they're not exact. They are 1 itself, like literally, mathematically, but they don't really quite look like they're 1 at all. This is known to be the fancy form of 1. That's what we call it in math. And in fact, actually, we're going to be seeing this quite a bit. You're going to hear me reference this term foo quite often, foo. And as a result, how that relates to our problem 73 is the fact that because we can't have this square root on the bottom, this square root of 2, we're going to go ahead and try and multiply it by something to try and get rid of that square root. Well, there's this other rule in dealing with square roots that says if you were to multiply it by the exact same thing. So the exact same thing on this bottom. Odds are, most of the time, like 98% of the time, unless there's some other number over here, you're going to be fine. Like things are going to be great. So let's go ahead then and just multiply it by the square root of 2. But on top, hopefully, you should be thinking, if it's going to be foo, the square root of 2 is on top as well. Because again, a moment ago, like we had several examples where we had like 3 divided by 3. Well, that's just 1. 5 divided by 5. Well, that's just 1. Square root of 2 divided by square root of 2. That's the same thing as saying 1. So because we're just multiplying this, sorry, I know I have a ton of arrows, but because we're just multiplying this by essentially 1, we are not changing at all the original problem. We're just going to be changing the way he looks is all. And so on top, we end up with the square root of 1 times the square root of 2. You can place that under 1 square root if you want. On the bottom, you kind of have that same thing. The square root of 2 times the square root of 2. Or just place it under the same square root. At this point, now we just have the square root of 1 times 2. Well, that's just the square root of 2. And on the bottom, we have the square root of 2 times 2. Well, that's just the square root of 4. So on top, we still end up with the square root of 2. But on the bottom, we have the square root of 4. Well, the square root of 4 is just 2. I know I keep going back and forth with 2's and 4's, but I'm sorry, that's the way the problem was structured. And then as a result, look, no longer do we have that square root on the bottom. It's just a regular number, in this case 2. So that would be our solution then for problem 73. Shifting gears now to 74. This one looks pretty intimidating, but it's actually not crazy terrible. So just don't let it like concern you too much, because it's actually not too bad when you start breaking it down. So we have our 3x out in front. He's not changing at all right now. Now the square root, there's a lot of stuff in there. So let's actually take things piece by piece. For a moment, let's just look at our 12, that number 12. So I'm going to set up, in fact, that good and garbage with just 12. Not worrying about x's, y's, whatever. Just the number 12. On the right, I'm going to have my list again. So like 1, 4. This is the list of perfect squares, by the way. 1, 4, 9, 16, and our number is 12, so we don't really need to go any higher than that. Is 12 divisible by any of these numbers? And the answer is yes. 12 is evenly divisible by 4. So we're going to go ahead then and put in 4 into our good. Now 12 divided by 4 gives us a garbage of 3. So we have that garbage left over. Now when it comes to our variables, this is where things, I guess, get like the most, I don't even want to necessarily say tricky, because it's not even like necessarily the best way to describe it, but we'll go at it step by step. So if you have the square root, the index, in other words, the number outside of that square root, because it's not written, it's actually assumed it's a 2 every time. If it's not written there, it's always assumed it's 2. Well, what we're going to do is, just for x's, we notice that we have this exponent of a 5. Okay? So right now, for the x's, this is just like a little chart, if you want to consider it. So just for the x's, we notice that exponent of 5. And for our index, we have a 2. And how we actually, kind of set up this like good and garbage with the variables is we can go ahead and actually just divide our numbers, or I'm sorry, our exponents here. So we end up then with 5 divided by 2. Well, 5 divided by 2 is just 2 and 1 left over. So 2 remainder 1. So 2 went into 5 2 times. We have a remainder of 1 left over. Now what that means is we can then take x, and the number that worked, in other words, it went in twice, that is now our new exponent. We still have a remainder of 1 left over, and as a result, we have the square root of x raised to the 1 power. That's where that exponent is still coming from. It's still there. It hasn't changed. For the y's and z's, they behave exactly the same way. So we're going to see that again right now. So again, really fast, that exponent for y is 4. We are dividing it by our index, 2. Well, how many times does 2 go into 4? It goes in evenly twice. And as a result, we have y came out cleanly 2 times. And notice there's no remainder at all. Like we had with x's, there's no remainder. So you won't even have like a square root of y at all. Like, it just won't happen. Again, just because it evenly went into that 4. Likewise with z's, we have z to the 8th, taking that power, that exponent of 8, dividing it by 2, coming in from our index. Well, 2 goes into 8 4 times. So as a result, it goes in actually evenly 8 times. So that's in fact going to be our exponent for z. There were no remainders left over. And so that would actually be it. Now I'm going to go ahead and kind of clear up some of this board space so we have a little bit more space to kind of finish it. We've actually done, at this point, all like the really hard work for this problem. Now it's just kind of finishing it up and cleaning it. But that's actually not too bad. So we have 3x. We can do the good. Square root of 4, that's just 2. Square root of 3. We have our x squared. Square root of x. Y squared. Z to the 4th. And now the absolute last step is combining our like terms. And by that I mean, like, we have a 3 out here and a 2 on the outside. We can't use this one because it's inside the square root, but we can multiply this outside one and this outside one. So 3 times 2 just gives us 6. And then we have our square root of 3. Now we can go ahead and multiply our x's. X times x squared. Well, if you have x times x squared, that's exactly the same thing as saying x times x times x. Well, since you have x times x times x, that's literally the same thing as saying x cubed. And likewise, this square root of x can't really be combined with anything, so he just drops down. And then likewise, the y squared and z to the 4th just end up coming down as well. Now, for me, honestly, that's actually okay. For some people out there, teachers, instructors, whatever, they actually like maybe combining these since they are considered to be like terms. So I'm going to go ahead and show that too. We would end up with still 6 on the outside. And a lot of times too, it doesn't matter to me, but a lot of people like the variables and everything that's clean on the outside all together. And then like anything with a square root, that kind of goes at the end. So we notice that we have a 3 and an x. So then in our square root, in our single square root, you can actually just write 3x. So that would be the most simplified version for this particular problem. That's actually probably one of the harder problems on this summer package. So if you were kind of like, having a hard time with that one, don't like freak out. We'll definitely talk about properties with exponents and good and garbage. All right. Moving on to 75. This is actually not that bad. I think 75 and 76 are a lot easier than the one we just did, simply because there are no variables at all. Now, we have the square root of 7. If you think about it, the square root of 7 can't really be broken down into like a good and garbage, so we're just going to kind of leave him alone. We also have times 4, but we can do a good and garbage for this square root of 8. Now, the square root of 8 just comes out to be, oh, you know what? Actually, there's an easier way. Well, we'll show both. We'll do both. You can break down the square root of 8 into 4 and 2 times 3 square root of 2. Again, we can't really break down the square root of 2, so that's why we just rewrote this guy. Simplifying this further, we end up with the square root of 4, that good one, is just 2. Square root of 2 times 3 square root of 2. In which case we end up with the square root of 7 times 4 times 2 is just 8 root 2 times 3 root 2. And with this, we're actually multiplying all the outsides with the outsides and insides with the insides. And what I mean by that is really there's a 1 out here. What I mean by that is we can actually go ahead and multiply this 1, this 8, and this 3 all together because they're considered to be on the outside of those square roots. So 1 times 8 is 8, times 3 is 24. Then we have our square root. And then on the inside, we have 7 times 2 times 2. Well, 7 times 2 is 14. Times 2 again is 28. And at this point now, you would just do some good and garbage with this 28. So we have 24 Here's my good. Here's my garbage. Going back to our list of perfect squares. 9, 16, 25. 28 is evenly divisible by 4. So we're going to throw 4 in our good and 7 into our garbage. Now the square root of 4 just comes out to be 2. We just rewrite the garbage. And then you just multiply 24 times 2. So that just gives us then 48. Beautiful thing, garbage just carries down. So that would actually be our solution, or most simplified version for this expression. Just really fast. In fact, the only difference than the other method I was just talking about was you could have actually multiplied these first, and your problem would have been a little bit shorter. But again, as long as you get the same answer in the end, you should be all right. So just really fast, like kind of the shorter way, would have been multiplying this outside of 4 and 3 together to give you 12. And then the 8 and the 2 would be 16. And then as a result, you would have ended up with the square root of 7 times 12. The square root of 16, you can actually do a good square root of that. So you don't have to worry about good and garbage. It's like literally just a number that you can pull out. So that would have just been 4. And so then you would have just ended up with 48 root 7. That actually would have been a lot faster. Probably should have thought about that one. So again, though, that is 75. You could have done it either way, really. Moving on to the last one, 76. We're going to go ahead and start out by doing good and garbage for every single one. But actually, let's go ahead and start out by doing our list. So 1, 4, 9, 16, 25, and that should do it. Square root of 32 we can break up into, we can divide that evenly by 16. Now, we know that we can also do 4, but as you're doing good and garbage, your goal is kind of trying to use the biggest one, because trust me, it does make your life easier. And if you try 4, you're going to see, why. So doing our good and garbage, we can break that up into 16 and 2. Because again, 32 divided by 16 gives you 2 for your garbage. Plus this 3, I'm just going to go ahead and rewrite. So that's not changing at all. Doing our good and garbage for the middle one, we end up with 18 can be broken up into using 9. 18 is evenly divisible by that perfect square of 9. So we're going to throw 9 into that good. And then 18 divided by 9 is 2. So that's where we're going to throw our garbage. Minus 2. Not changing that at all. Establishing our good and garbage. And then the same thing. 50 we can break up using our list of perfect squares. It's evenly divisible by 25. So we're going to throw 25 in our good and 2 in our garbage, because 50 divided by 25 just gives us 2. So at this point, now we're going to go ahead and actually apply our square roots to those goods. So the square root of 16 just comes out to 4, and we're going to carry down our garbage. So plus 3, that again, not changing that 3. Square root of 9 is just 3. Rewrite the garbage. Minus 2, not changing that negative 2 either. Square root of 25, that good is 5. Square root of 2. And at this point, we're going to go ahead now and multiply our outsides with our outsides. So that really only happens here and here. This 4 root of 2, we'll just rewrite 4 root of 2. So 3 times 3 just comes out to be 9 square root of 2. Negative 2 times 5 comes out to be negative 10 square root of 2. And since all of these have square root of 2's, we can go ahead and combine all of those outside numbers. So like 4 plus 9 is 13, minus 10 is 3. And then we also have our square root of 2. It's kind of like back in algebra where you have like 5x. Actually, we'll even just use the same numbers. It's kind of like if you had 4x plus 9x minus 10x. These square roots, all of them, behave identically like variables, like x. And as a result, since they are exactly the same underneath all the square roots, you can then just kind of go ahead and combine them to get your 3x, or 3 square root of 2. So again, though, that is problem number 76. Once again, I really appreciate the individuals who told me about this, that the link was dead. Not sure why, because it was definitely up there for last year. So, all right, guys, you should have everything that you need to complete now that summer packet. But if you have any questions, obviously feel free to email me.